Hello everyone, and once again welcome back to the Chem School. Now you know that we have started with a very important chapter in inorganic chemistry, which is nothing but the coordination compound. Until date we have covered most of the basic stuff that is needed to build up the most difficult concept in this chapter. So today we'll start with one important topic, and that is nothing but the IUPAC nomenclature. Okay, and that we are talking about only for coordination compounds. Why? Because if you have had a look to all my previous video, you know that I have vastly covered IUPAC nomenclature for aromatic compounds, okay, for hydrocarbons, for all the functional groups. So only topic that was remaining in IUPAC nomenclature was coordination compounds. Okay, so let's start with this in detail today. Now let's make this topic interesting, and how we can do that. We will not take all the rules first. We will understand the concept, and while solving examples I will explain you the rules, so that will be easy for you because you are solving the examples at the same time you are also learning about the rules. Okay, so now if you talk about any coordination complex, how it is written as, this. I have taken one complex which has almost everything. Okay, so have a look at this. We know very clearly because I have already explained you this before. Okay, so have a look. Now you know that before the square bracket whatever you have, okay, that is nothing but your cation. Okay, and the cation from where? It is a cation from your primary valence. Okay, after the square bracket is also your primary valence, but that is nothing but an anion. Like suppose if you write KCl, you will write potassium first and chloride afterwards, right? So potassium is your cation and chloride is your anion, as simple as that. So when you write a complex, it is also like a salt. Outside the square bracket is your salt, in which you will write your cation first, okay, and you will write the anion at the end. That's the same thing, but in between the square bracket you will have your coordination complex. Okay, so now let's write down the name of each one of them. So the first one is potassium, and we said that this is nothing but a primary valence. Okay, and primary valence what? This is your primary valence cation. We'll just change the color of the pen. Okay, this is your primary valence cation. Okay, next, outside the square bracket again you have one more ion, and that is also your primary valence. But what was that? That was your primary valence anion. Why it is important? Because primary valence name also will write like the salt. Okay, so if you say KCl is potassium chloride, so even in the complex the name will be the same. That is, you will call this as potassium and you will call this as chloride. Okay, so anything outside the square bracket, their name will be written like the name of the salt. So this is very simple. You know how to write down the name of the salt. So one thing is definitely sorted. Let's talk about the other part, that is in the square bracket. In the square bracket, immediately after the square bracket, you will have your coordination central metal. Okay, or you will have your central metal. Okay, so everything inside your square bracket is your secondary valence. Okay, so this is your secondary valence, and this is also your secondary valence because it is also inside your square bracket, but they are different. Okay, like this were different. One was cation, the other one was anion, right? Similarly, in the square bracket, this is your central metal atom, or you can say it is an ion. Okay, and here this is nothing but your ligands. Okay, this is nothing but the ligands. Fine, so they all can be of different type. Ligands, we know, we have studied the classification of ligands. You can have a huge varieties of ligand. That is not a problem. We have seen their name as well. Okay, so for now this has to be very clear. Okay, now once you know this, the second thing that you should know is the sequence of writing down the IUPAC name. Okay, once you know what is your primary valence, what is your secondary valence, now let's find out the order. Okay, so when you talk about the order, okay, in this what we have right now, we will decide the order. Okay, so the order is, you will always write down the primary valence cation. Okay, so let's do the numbering. Okay, let's say that this is 1, this is 2, this is 3, and this is 4. Is that clear? Fine, so you will write down the order will be 1, okay, followed by the ligands. Okay, so after 1 you will write down the name of 3, that is whatever the ligand is there. okay, in alphabetical order, of course. If you have primary valence of different names, again you will follow your alphabetical order, okay, like you have sodium and potassium, right? So again follow the alphabetical order and write accordingly. So here if you have ligands, different ligands, okay, you have chloro and bromo, okay, chloride or bromide, so in that case you will again write down the alphabetical order, B followed by your C. So after this you are writing down the name of the ligand, then you will come to the name of the metal, okay, and last you will write down the name of the primary valence anion. Is this clear? If the anion is there, then you will write down the name of the anion. Sometimes, okay, instead of writing down the name of the anion, they will write down the charge. That is, instead of Cl, they will write down the charge as -1 up there, okay, or +1 up there. So in that case you will have to write down the charge instead of the name of your anion. So we will see all this thing later on when we solve the examples, but for now the sequence has to be clear. Primary valence cation followed by the name of the ligand in alphabetical order, followed by the metal, and followed by the anion or the charge. Is that clear? Fine. So this is what you should know for now. So now we know that the primary valence are written as salts, okay, so we are not going to bother about it. So the names will be like the name of the salts, same as the anion and cation of the salt. So now let's talk about the naming of other stuff, that is the secondary valence metal, okay. So whenever you talk about the IUPAC nomenclature, you will come across two types of naming, okay, that is somewhere, some places you will find as metalate, okay, that is ending with 8. So metal will have 8 ending, and some places you will see that the name of the metal is written without any 8, okay, like for example in this case you will write orate, okay, and sometimes you will just say aurum. Now let's understand when to say that, okay, when to use mate. So if you have a complex which is anionic, okay, that is an anionic complex that has your ligand which is anionic, only anionic ligands, okay, there should not be any other type of ligands. So if you have only anionic ligands, in that case you will attach ATE. So in case of ferrum, that is iron, that will become ferrite, okay, gold is aurum, that becomes aurate, copper becomes cuprate, molybdenum become molybdate, okay, and so on. Fine. So we are attaching 8 when we have only anionic ligands. But what happens when you get a mixture? That is, you have a neutral ligand that is donating a pair of electron. You know that in anionic ligand you will have the negative charge donating the electron, that is also a pair. But in this case, in a neutral ligand, if you are having the lone pair which is the donor, okay, if all of the ligands are neutral, then you will just say metal, that is aurum, iron, cobalt, molybdenum, and so on, okay. If you have a mixture, that is, let's say you have chloro and you have ammonia as ligands, you have 2 ligands in the same complex, still in that case you will just write down metal, you will not use the word 8. Why? Because ammonia was present there, which was a neutral ligand. So it means that even if you have one neutral ligand present, okay, or if you have a neutral ligand present, then what will be the name of the metal? It will be just metal. And if you have an anionic ligand, only anionic ligand, then the name becomes metallate. So I hope this is very clear. So in this case it is very clear, okay, that you have only one type of ligand, that is Cn minus, okay. Therefore for gold you will write down aurate. Is this clear? Fine, no doubt about it. Now while doing the IUPAC nomenclature, the maximum rule that you need to remember is for the ligands, and it is not that much also. Why? Just have a look. These are very simple and you know most of them, okay. Now when you talk about the ligands, the first thing that you have to remember, I already said that you have to write down the name of the ligand in alphabetical order, okay, right? If you have 2 or more ligands, then you have to follow the alphabetical order. It's so simple, right? The next one, if you have anionic ligands like chloro, bromo, iodo, cyano, nitro, okay, nitrito, and so on. So for anionic ligands, it will end with O. You have seen that. Yes or no? You have listened to that, right? So it is very simple. All your anionic ligands, while writing it down, it should end with O, right? Next, if they are getting repeated, like in this case, you can see there is 4 cyanide. So you will say tetracyano, while writing down the IUPAC nomenclature. So that is what we are talking about. So use prefixes like di, tri and tetra on repetition. That is, if the same ligand is getting repeated more than once, then you will use this preference. Okay, you will use this prefix, right? Next, for chelates, that is, now you know that di, tri, tetra we are using for monodentate ligands. Okay, I repeat, it is only for monodentate ligand. But what if a ligand is donating 2 pair or 3 pair of electrons? Then it becomes a chelate or a polydentate ligand. So for polydentate ligands, you will use the prefixes like bis, tris, tetrakis, pentakis, and so on, right? And the last one, again the order. For the ligand, the neutral ligand has more preference over the anionic ligands. I repeat, the neutral ligand, when you write down in a square bracket, let's say the name is given and you are supposed to write down, the formula for your complex. So while writing down the formula, in square bracket, you will first have your neutral ligand and then you will have your anionic ligand. That is what I mean to say. Okay, so again, the preference of writing down the name or the preference of writing down the structure would be like, you will have the primary valence cation followed by the ligands. In ligands, you will have the neutral ligand preferred over the anionic ligand, followed by the name of the metal, and at the end you will have the primary valence anion. I hope this is very clear. Simple. I repeat it once again, the rules for the ligands: alphabetical order. Okay, the next one is the anionic ligands. Whenever you have anionic ligand, they should end with O. For neutral ligand, the name is usually the same. For some of them, there is an exception. For example, for water, we don't write water, we write aqua. Okay, but for ammonia, we write ammonia. For ethylene diamine, we write ethylene diamine. Okay, so there has to be some exception because it is chemistry. So by now you should know that. Okay, prefixes we are using, I repeat, di, tri, tetra and so on for monodentate, for chelate, bis, tris, tetrakase and so on. And the order is very easy to remember. That was all the rule if you want to write down the name or IUPAC name for the coordination compounds. Now let's solve some examples. Now I have taken these examples, and if you can see, these two examples are very different from each other. Why? The first one, if you talk about, okay, calculate the oxidation state of the metal. Okay, so when you calculate the oxidation state of the metal, what you will find? Okay, so +1 -1, that is already gone. Okay, that is neutralized. Here you have -4, it goes on the other side of equal to, and that becomes +4. So here the charge on AU is +4. Okay, so you can see that this is an ionic complex. Okay, the first one is an ionic complex, and especially when you look at the ligands, you can say it is an anionic complex. But the second one, carbon monoxide is neutral ligand, so the charge on nickel is 0. Okay, so this is a neutral complex. So when you write down the name for an ionic complex, that is anionic complex, and the name of a neutral complex, there is some difference, and that is what we were talking about, the mate and the metal. Okay, so let's apply it here. Write down the name of the first complex. Okay, so first order will be your potassium, followed by your ligand. Okay, and because it is a monodentate ligand, it is getting repeated 4 times, so tetra. So tetra because it is an anionic ligand, the ending will be O, cyano. Okay, so potassium tetracyano. Next, the name of the metal, that is orate. After that, you have to write down the oxidation state of the metal. That is the reason we are calculating it, and that is the reason I took a separate video on oxidation state of coordination complexes. Okay, fine. So let's take. So now you will write down this oxidation number in parentheses, that is bracket, and in Roman numbers. So this is 4. Okay, so this you have to remember, that you have to write down the oxidation number of the metal even if it is 0 in round bracket, that is parenthesis is going to be this. Okay, and this has to be in Roman number. Okay, the last one, you will write down the name of the primary valence anion, and that is chloride, like the salt. Is this clear? So that was so simple, isn't it? You just need to remember the sequence of writing down the name. And you can see that it has 8, so it is metallate form. Okay, next one. This is having 4 carbon monoxide, so you will say it is tetra carbonyl. Carbon monoxide is carbonyl. Okay, so it is tetracarbonyl and nickel. Okay, and nickel has the oxidation state of 0. Is this clear? This was so simple. You can also call it as nickel tetracarbonyl in common name. Okay, so nickel tetracarbonyl is common name. In IUPAC, you can say it is tetracarbonyl nickel and followed by oxidation state. This is a neutral ligand. So these two examples were very simple, weren't they? Okay, so today what I want you to do is, whatever we have read, I want you to apply. In the next class, we will have a look at all the charts and we will take more complicated examples and we will solve a lot of examples in the next class. So today's video, just try to collect all the concept, try to understand it, and based on that try to solve some examples. See you soon in the next class. Thank you. And don't forget, I'm going to attach the link for the previous IUPAC videos, not all of them, few of them. Okay, so just try to go through it. Thank you.